Good morning. We're live from San Diego,
There you go.
also known as Whale's Tail. We're doing lesson 10. Yeah.
Sweet.
Mason's a little red today.
Yeah, my camera looks like my camera's making some improvements here.
If the teacher or the TA sees this video, make it known to us somehow.
Leave us a comment.
Follow me on Twitter.
All right, anyways. All right, so what's the first one? Question 3. Find the margin of error for 90% confidence interval. Where's my notes?
Find the margin of error for 90% confidence. So is this going to be 0.9?
Yeah, you have to use a z-score of 0.9.
Oh.
You use a z-score of 0.9, and then you get here we go. So you use a z-score, or you do 90% for the top part of the normal probability, and then you fill in the middle part, and it gives you a z-score of 1.6. So then you use the equation. The formula is, let's see, margin of error. My calculator. So I think to find the margin of error, which they called out the letter M, it's equal to the z-score multiplied by the standard deviation divided by the square root of the sample size.
Which is 5. So it'd be 1.6 times 50 divided by 5. Is that right? No.
Yeah, that's right.
What are you solving for again?
The margin of error.
Did you get 16.45?
Yeah. It does say round. I might be doing it wrong because it says round to 3 decimal places and there's only 2. But
yeah.
I don't know. I don't think there's another way to do it. But, what did you guys think? What do you think about that? Does that sound right?
Yeah.
Yeah, it sounds good to me.
Okay. All right. So for
0.4.
Yeah, question 4.
Which of the following statements is true?
I remember there's a chart. Where is it? Oh, if you go to 3.1. In
the point estimators?
Yeah, point estimators. Basically how I'm interpreting this little chart is there's the sample statistic and then the population parameter, and the parameters are like the knowns. That's the big one. And so if you can use this x to find use this x mean to find the population parameter. And that was the only one that kind of lined up was the x. Wait. Yeah, the x with the line on top is a point estimator of U. So it's like the sample mean points to the population mean.
Mean is U's known, unknown.
So number 3.
Or number 4.
Yeah.
So the third one.
The second one. right?
Yeah, the second one. I'm not 100% sure about that, but if you, yeah.
Oh, sweet. Computer's on.
Ooh.
Okay. Let's go. You want to do question 5 now?
Just trying to understand better point estimator and interval estimator.
I can tell you what I think they are. I don't know. I think a point estimator is like if the parameter is actually 40, say you get the sample and it's 39, because it's just one number, it's a point estimator. But to calculate an interval estimator, it would be like it's from 39 to 41.
Okay.
So to get the interval, I'm just reading 3.2. You start with that point estimate, and then you add or subtract the margin of error. And the margin of error is, use the formula for that to find that. But I don't know. In part 4, I didn't realize there was this 2 in the equation. I thought it was z.
Yeah, I was kind of just looking at that.
Maybe.
So it's supposed to be 1.6. Wait, is it supposed to be 1.6 times 5 divided by 100?
Yeah, 1.645 times 50 divided by 5.
Isn't it supposed to be multiplied by 5?
Well, the standard deviation goes on top, which is 50.
Oh, I was thinking something different. Wait.
Like if you scroll down to 4.1.1, it uses.
Pulling everything back because my computer just turned back on.
So.
Because you're saying, isn't it? Didn't you say it was z equals x minus m? Or is that something way different?
The z-score equals, well, I'm not exactly sure how to use the formula, but if you go to the normal probability applet and you type in 0.9 for the area.
Right, you get 1.64 for the z.
Right.
And then did you just do x minus the mean divided by standard deviation divided by...
No, you don't use the mean. You use that z-score of 1.645.
Find the margin of error.
So the margin of error, you don't use the x part yet. You're just calculating the. If there's an equation where it's m margin of error equals.
So I think we just do 2 times 50 over.
But they just used 2 as an example. If you keep scrolling down.
We're trying to find that 2.
Yeah. And there's a chart. If there's a chart, like in 4.1.4, it tells you what the 90, the 95, and the 99 are. the z-scores for those, and you should just write them down on your paper because they only ask for those ones.
90 is 1.645. 95, 99, 2.56. So z-score.
Sorry, I had to go to the bathroom.
You're good.
What question are we on now?
Aaron, what question you on?
So what did you get for number 3?
16.45.
Oh, okay. Yep, that's what. And then we're on 5, right?
Yeah.
All right. Christy, can you get my charger? Yeah.
So for question 5, the point estimate I think is 526.
Yeah.
Does that make sense? For question 6, what is the margin of error for the 95% confidence interval for the true GMAT score? So I calculated the margin of error is 27.685.
27.865.
0.685.
0.685.
Yeah.
All right. Gino wants to construct a 95%. 95% was 1.96. What is the point estimate for this? So for the point estimate, did you just do?
It's 526.
But did you just do X plus?
The point estimate is just X.
Oh, it's just X? Oh, that's right. And then everything else is up and above it. So then
And then how did you calculate number 6?
So number 6, use the equation m equals the z-score multiplied by the standard deviation, and then all those two divided by the square root of the sample size.
Okay.
And then so you take that number and you add that and you subtract that from the point estimate, or X.
So for you got 498.315 for 7.
Yeah. Is that what you got, Mason?
I'm looking at the reading
Oh, okay.
right now.
55. 1.96.
The summary at the very bottom, step 7, gives like a good synopsis, I think.
Where is that?
It's part 7. It's like at the very bottom of the reading.
Okay.
What would happen to the width of the confidence interval if Gina increased the sample size? It would get smaller. Wait, how many people did you do?
What would happen to the width of the confidence interval?
You get more sample, the smaller it gets, right?
Yeah, yeah. If the bottom of the denominator keeps, if that increases, then it should decrease the overall number.
What would happen to the width of the confidence interval if she changed it to 99%? It would increase?
I think so.
Because it's not dividing you, right? It's just multiplying.
Yeah.
So for the what's the difference in the equation for lower limit and upper limit?
Adding and subtracting.
Oh, that makes more sense.
We'll say these onions take days to cook, though. All right, number 11. Bright bulb, light bulb. Okay, so this is going to be 1.645.
I think it's 95%.
Let's see. So 1.645. What equation did you use for that?
For which one? For 11? I think you have to move the equation around to solve for n.
So yeah, so you have standard deviation over the square root of n, and then is that multiplied by your z?
Yeah.
Oh yeah, 1.645, and that equals the number you want.
Right. Well, and then I think.
And that's going to be 95%.
Let's see. Wait, what's the m that they want?
So
What's
they
the
want.
margin? Oh, they want an error margin of error of 50.
So they want that to equal 50.
Yeah, they want m to equal 50. So for 11, what I'm not sure if this is right, but I'm doing m divided by, and then in parentheses on the bottom, the z-score times the standard deviation.
So I did 50 divided by 1.64 divided by 400. Then you take the square root of that, and then you do 1 divided by that to get the reciprocal, right?
Yeah, I think so. I'm not sure on this one.
2.
Oh, right.
And what sample size do they need? Oh, I don't think that's right. That don't seem right.
Okay, so this is what I think you need. I think what you got to do is do z times standard deviation divided by margin of error, and then square all of that.
I don't know if that 50 is right.
Well, it's given. It says they
3
want.
So I think the 50 margin of error of 50 hours. So did you get 3.622?
No, I got 246.
And you did 1.64 times 400 divided by 50?
No, it's 1.96.
Oh, because it's 95.
So I did 1.96 times 400. 1.96 times 400 divided by 50, and then squared that.
Oh, square it. I'm an idiot. 245.862?
Yep. But it says just round to the whole number.
Oh. 246?
Yeah, 246. If you look, though, in the example he just said if you get 101.2, round to 102, which doesn't make any sense, but.
Well, I think it's just because, like, you got 0.2 person, so you got to go up one.
Go up to it. Yeah, I guess that makes sense, but.
All right, number 12, the mean salary of actuaries. You are interested to know the mean salary for women. Not sure. You set up a hypothesis to test the significance level of that. You collect a simple. Why are you putting a little W? What is the limit of the 95% confidence? So 1.96. How'd you start this one?
So I just took, they want a z-score of 95, right? Yeah, 95. So I did 1.96 multiplied by 36,730.
You use that even though that was the male one? Oh, does that just...
That's just the standard deviation. And then I divided that by the sample size.
That's it?
The square root of n, right?
Yeah, the square root of the sample size.
6.
1. So you got 11998.
Yeah. So that equals the margin of error. So then you have to do the 111,000 minus the answer that we just got.
Gotcha. 111,000 minus the answer. And so you got 99001.
Yeah, 99002, but maybe I just rounded weird. Let me. Is it 99001 or 99002?
So I didn't do any rounding until the very end. Oh, it is 2. That's a 5.
It's 99001.53.
It rounded the whole number.
Yeah. And then so what would change on number 13 in that equation?
We add instead of subtract.
Oh, so it'd be...
Yeah, so 111,000 plus the 11998.46666.
So are you doing 122,999?
Yeah, 122. I put 998, but maybe
Requirements that need to be checked when computing a confidence interval mean they are X is normally distributed.
It's X is all of the above, I'm pretty sure.
Yeah. All right, sweet. I think that's good for this week's chit chat.
Okay, sounds good. I'll end it.